So this is the easiest way I could find to synthesize lead borate in a home lab, and everything here is either going to be an OTC chemical or something that can be made easily by way of OTC chemicals. So we just need these three things here. This is distilled water, and I just took it out of the microwave. I had it in there for 3 minutes. So it's near boiling, so we want near boiling distilled water. And this big beaker here, you can see there's a stir bar in there. I've already got 11 grams of sodium tetraborate, otherwise known as borax, in there, which can be found at pretty much any grocery store or Walmart, anything like that. In the cleaning section, it's used as a laundry booster. And so in here, this is the only thing that's not completely OTC, and this is lead nitrate. I did show how to make this by way of OTC materials, starting all the way back with the nitric acid in a previous video. So if you're not sure how to make lead nitrate, if you want to and you need some, go ahead and check out that video, and it shows the synthesis for lead nitrate. If you don't know how to synthesize nitric acid and you need some for the synthesis, then I suggest checking out probably either Nile Red or Nerd Rage's channels. They both do a pretty good job of showing how to make red fuming nitric acid. So that's nitric acid at 86% plus, and I believe that Nerd Rage also shows how to do a 30% synth. And Nile Red, I think, also does an azeotropic synth. But you want at least azeotropic for this, which is 68%. Anyhow, I'm not going to go into that anymore because, you know, that's the lead nitrate synth, and this is the lead borate. So let's get rid of our nitrate. Let's get our stirring going here, and we're going to pour in here. Again, this is 11 grams sodium tetraborate. Let me see. Previous run, I was able to get this to dissolve in about 80 milliliters of water or so. So that's what we're going to try here. I can turn the stirring up a little more, and you can see immediately it, you know, kind of, you get condensation, so you can't see through it anymore. But so we're going to let this stir, and while that is stirring till it's dissolved, I'm going to go ahead, throw our lead nitrate back on here, and you can tell my lead nitrate is very gray, and that is simply because when I made it, it was a little bit dirty. I used recycled lead, and I did not really, I just kind of cleaned the lead up a little bit with some acetone and a brush, and it didn't get it clean enough. And I also did not allow my run to go all the way to completion when I was making this lead nitrate. So it's a little bit gray because of some dirt contamination, and then also because there is some unreacted lead in here. And because of that, I'm going to have to filter out any impurities in this. You can see now it looks really gray as I pour it into this solution here. If you guys are using lead nitrate that you made properly or bought, it can still be a very slight grayish color. That's normal. However, there shouldn't be anything left behind. Lead nitrate is somewhat soluble in water. So as long as you have enough water, you should be able to get it to go all into solution. If you have anything after about 10-15 minutes of stirring that just will not go into solution, then you're going to want to filter that out, because at room temperature and colder, lead nitrate, you know, it can form a suspension because it's not super soluble, as most lead salts are not. However, it's soluble enough that it should all go in with our 6 grams in 100 milliliters of water. Hot water is what we have here. So I'm going to let these stir for a little bit, and when they are ready, I'm going to come back. I'm just going to throw a little lid on top of that guy. And our lead is kind of full too, so I'm going to throw a lid on top of that. Alright guys, I'll be back shortly. So I just took the pH of the tetraborate solution, and you can see there we are a solid 10 as far as our pH goes. And so after we add our nitrate is basic, but it's just slightly basic. I mean, you're talking like between 7.5 and 8. We should expect to see our pH then be lowered down to somewhere between 8 and 9. I'm thinking it's going to be right around 8. So we'll take the pH again after we have mixed our two solutions and let them go together and react for a while. So almost ready. We've been stirring for about 5 minutes here. You can see the tetraborate is almost completely in solution. Still just slightly cloudy here, so I'm going to add just a skosh more water, another 5 milliliters. There we go. And we'll just let that stir for a minute. Let's check on our lead nitrate here. This is the one that's going to take longer. And so it looks pretty good, except for you can see, like right there, there's a little chunk of lead you can see in there. Let's see what the rest of this looks like. And now, I'm not wearing gloves currently. I did have gloves on as I was weighing out the chemicals because these are lead salts, and so you have a very toxic chemical in the lead, especially being that it's salts. And you definitely want to wear gloves for this. You do not want to be handling the stuff without gloves. And also turn off any fans that you may have, and do this where you are in either a very well ventilated area like in a fume hood or outside, or do it inside where there's no breezes or fans that can be blowing, because you do not want to inhale the lead dust. But so my point is that I had gloves on when I weighed the chemicals out. Right there I just touched the outside of the beaker, so you know there's no chemicals, no lead dust or anything on that. However, when I go to mix the two solutions together, I'm going to throw the gloves back on. That way if I spill any of the lead solution onto my skin, I don't absorb it. Alright, so everything is stirred as much as it can be, whatever. And we don't want to let these cool off too much. We want to mix them together while they're still warm. So I'm going to go ahead and get our stir bar up out of here, pin it to the side of the glass here, and I'm going to go ahead and I'm going to filter my nitrate directly into our borate. And since it's less than 100 milliliters of solution here, I'm just going to hold the filter in my hand while it goes through. It's not going to take very long. And what we should see is an immediate bright white precipitate form, if we did it right. And there it goes already. You can see it clouding up. Turn my stirring up just a little bit. Oh, I forgot to put gloves on. I just was saying about how I was going to do that too, and I forgot. But I'll just be extra careful not to splash any of this lead solution on myself. Wear gloves when you're doing this at home, people, though. Don't do as I say, not as I do in this situation, for sure. Do not want to be messing with lead salts. They're very toxic, much more so than even, elemental lead metal. And that's, simply because the salts generally are pretty absorbable readily through the skin, and they actually present even more of a danger than skin absorption in the fact that you can breathe the powder and the dust of the stuff. That's where any chemicals really are they have their most toxicity when you're dealing with the powder, at least as far as dry chemicals go. And as that powder, it can get into your eyes, can get kicked up in the air and it be inhaled. And so then whether it's inhaled into the mouth, into the lungs, into the throat, or just into the eyes, your eyes are vitreous. So, because of that fluid in there, anything that gets into them is going to turn into its acid or base, respectively. For one, you got that potential hazard. For two, you're going to absorb it into your bloodstream through your eyes, and it's going to happen pretty rapidly. And you're going to also absorb things into your bloodstream from your mouth and throat too. You don't have to suck it all the way into your lungs in order to get it into your bloodstream. So, yeah, the salts of chemicals are definitely the most dangerous form of dry chemicals, in my opinion, anyhow. And I know a lot of people that would agree with me. I'm going to kind of just stir this up a little bit as I am waiting for this to filter. I can see we use 6 grams of lead nitrate salt here, and probably only about 4.5 of it actually is in solution, because we have a bunch of unreacted lead powder in here. So that's going to hurt our yield, and it's going to make it to where I can't really calculate a yield for this, because we go off 11 grams of tetraborate and 6 grams of lead. We're going to end up getting a lot lower yield than what we think we did, just because we really only have 4 to 4.5 grams of lead in here. I'll know better once I get all the solution out, but I'd say we definitely, well, probably more like 4.5 to 5. There's probably 1 gram to 1.5 grams at the most in here. But this is just a demo that I had a viewer ask me about. He was curious as far as easy way to make lead borate. I'm not sure why he wanted it really, but I do know that lead borate is used quite often as a lapidary glaze, pottery glaze. I'm not sure why that is. Maybe because it's so unreactive, it makes a good glaze. I'm not sure, so he might want it for that, but I guess my point is that I'm just doing this just to show people how to do it. I don't have any use for this immediately. That's also why I'm doing it on just a big enough scale so you guys can see a proper representation of it, but not so big of a scale that I used up all my lead nitrate to do this. I'm assuming this could probably be done with lead nitrate and boric acid as well. You might have to add a little bit of 6% hydrogen peroxide though to get the acid to oxidize the lead nitrate. However, because boric acid is a pretty weak acid, I think its pH is only around 4.5 or 5. So it's pretty high pH for an acid. I mean, it's actually weaker of an acid than acetic acid is. But I didn't try this with boric acid. I figured the easiest way would just be the double displacement or metathesis with 2 different salts that I have. And I kind of thought too that the tetraborate would be a good salt to use. As far as borate salts go, I have perborate also, and regular borates of various different metals. And because the tetraborate has actually got 4 borate anions per molecule, I think that it might actually give us a better yield here. And if anything, if it doesn't give us a better yield than we would with getting with using borate or boric acid, it might help allow the reaction to go to completion a lot more readily without any external heat or catalyst added to it. Because after all, boron is not all that reactive, and lead, even though it's in nitrate form, is pretty damn unreactive. Lead is an extremely unreactive metal. So that's why I'm thinking, a catalyst might have to be used with the boric acid method, but when you're doing this, you're just doing a straight double salt metathesis, so metathesis, however you want to say it doesn't really matter, same difference. So I've got pretty much all of my nitrate solution in the filter now. While this is still going in, I'm going to take this little squeeze bottle and rinse the residue in my flask one time with 10 or 15 milliliters of distilled water. This will help not only wash off my stir bar that's in there, but also any of the nitrate that was stuck to the sides of the beaker or that is stuck to the lead metal that's in here. It will wash that free and allow me to get my maximum dose, if you will, of my solution in. With so I guess like the simplest way to say that would be with the least amount of mechanical losses possible, but I like to make things ultra complicated sometimes. And so this is going to be a short video, I'm thinking, because so you know, after we're done here, then we've got two things to do. We're going to heat this up and reduce the volume of our mother solution here by about 2/3 at least, anywhere between 2/3 and 3/4. Or I'll say 2/3 and 5/8, you know, somewhere in there, because 3/4 is sometimes a little bit too much. I'm not sure exactly. I did not look at the decomposition point for lead borate. But I'm assuming that as long as we keep it, you know, 100 C-ish, that we shouldn't have any problems there with decomposition. So then we're going to heat this until that point that I mentioned. Then we're going to chill it in an ice bath of the fridge and filter it off using whatever filter method we want. You know, obviously gravity is always, you know, a go-to option, but I have vacuum filtration, so this is kind of fine powder particulate. It looks like it's going to be anyhow, so I'm going to go with probably my Buchner funnel with filter paper instead of a frit, and I'm going to vacuum filter it. So I don't know if I'm going to show that or not here on this video. I mean, all you guys know what the filtration looks like. Yeah, so I think I'm just going to cut this video off and you know, call it quits. So give it a thumbs up if you liked it. If not, give it a thumbs down. If you really want to see the crystallization and filtration of this, I mean, leave it in the comments. And you know, this is going to be in the fridge for probably up to 72 hours cooling down. And it's going to take me, you know, an hour or two to evaporate this down. So if in that time you guys decide that you have to see the filtration and crystallization processes, then let me know and I will film it. If not, I will see you guys on the next video. Let me turn the stirring off though here quick before I call it a day, and I will get a better close up here. So there you guys have it. That is what our lead borate looks like, and my camera would focus. There we go. So we started off with a white powder and the tetraborate. That turned clear in solution, so that white was gone there. And then we started off with a grayish white powder in the lead nitrate. And now we have got the camera, you know, usually, as usual, it doesn't do it justice here. This is actually like a milk white substance, even though it's showing up pretty good on camera. It's just milk white. However, it's not very viscous, you know, it's real thin. So that's proof that we have made our lead borate, as opposed to having just, you know, nitrate precipitate back out, or the sodium tetraborate precipitate back out. Because if it was just the tetraborate, we would have a clear solution And if it was the nitrate, we would have a like kind of yellowish gray solution, clear but yellowish and gray. So there it is, guys. Hope you enjoyed. See you next time.
Try to open up my heart. I am ridiculed and torn apart.